solve the equation z the power n minus 1 equal to z bar, where n is belonging to the set of the natural numbers. So for this given equation, if I suppose the natural number to be as, let's say 2, then what happens? If I put n equal to 2 over here, I get 2 minus 1 as 1. That is equal to z bar. So z is equal to z bar, which means z must be a real number, right? So this implies z is any real number. So let's say suppose n is not equal to 2, right? Then z the power n minus 1 is equal to z bar, right? Let's take mod on both the sides. What do we get? We know that mod of z bar is, right, mod z. Your z is x plus iota y, right? And z bar is x minus iota y. If you take the mod of z, what do you get? X cube plus y square under the root. If you take the mod of z bar, then also what do you get? Square of the real part plus square of the imaginary part and under the root. So both the mods are equal. So this implies mod of z the power n minus 1 is equal to mod of z. In turn, I can write this as mod of z the power n minus 1 can be written as mod of z the power n minus 1, right? So that is equal to mod of z. Taking the z to the denominator, we get mod of z the power n minus 2 equal to 1. Fine. So this implies mod of z is equal to 1. Now when mod of z is equal to 1, so z is of the form, yes, z equal to, in the polar form, cos of theta plus iota sine of theta. Fine. Let's put this value back into the equation. That is, the given equation is z the power n minus 1 equal to z bar. So let's put z equal to cos theta plus iota sine theta over here. So this becomes cos of theta plus iota sine of theta the power n minus 1 equal to, this is cos of theta plus iota sine of theta bar, which means this becomes cos of theta minus iota sine of theta, right? Okay, let's write this further as cos of theta plus iota sine of theta the power n into cos of theta plus iota sine of theta the power negative 1. That is equal to cos of theta minus iota sine of theta. Using the de Moivre's theorem over here, we get cos of n theta, the power gets multiplied with the angle, plus iota sine of n theta. And here we get cos of theta minus iota sine of theta, because cos of, if this power is multiplied with this angle, cos of negative theta is equal to cos of theta. So it remains cos of theta as it is, and sine of negative theta is negative sine of theta. So it becomes negative iota sine of theta, right? So this is equal to cos of theta minus iota sine of theta. These two cancelled out. So we get cos of n theta plus iota sine of n theta is equal to 1, right? This implies cos of n theta is equal to 1 and sine of n theta is equal to 0. Then only this can happen, right? Okay. Now when cos of n theta is equal to 1? When this angle is equal to, yes, 2m pi, where m is belonging to the set of integers, right? And when sine of n theta is equal to 0, yes, when this angle is equal to 2m pi again, right? Where m is belonging to the set of integers. So for both the conditions, we are having n of theta to be equal to 2m pi, right? So from here we get the value of theta to be as 2m pi over n, where m is belonging to the set of integers and I'm taking the positive ones, 0, 1, 2 up to n minus 1. Why I have written here n minus 1? Because here n is a set of natural numbers, right? N is belonging to the set of natural numbers. So if you put all the natural numbers over here, you will get the set of all integers, right? So that is why m is 0, 1, 2 up to n minus 1. So putting the value of theta back to this z, so we get z is equal to cos of 2m pi over n plus iota sine of 2m pi over n, where m is 0, 1, 2 up to n minus 1, that is a set of all integers, and this value also satisfies z the power n minus 1 equal to z bar, right? So these are your set of solutions. Thank you.